Hello, my name is Alice, and I am pleased to present the sources of nutrients and their impacts to water quality in the Qu'Appelle River watershed. Welcome. We are the Lower Qu'Appelle Watershed Stewards located in southeastern Saskatchewan, and we cover approximately 17,800 square kilometers. Forming the lower or downstream half of the Qu'Appelle River Basin, the Lower Qu'Appelle River watershed begins near the town of Craven and ends at the Manitoba border. The river flows through 6 major lakes from west to east. These lakes include Pasqua, Echo, Mission, Katepwa, Crooked, and Round Lakes. Major tributaries include the Pearl, Indian Head, Red Fox, Ikapo, Cutarm, and Scissor Creeks. The Lower Qu'Appelle watershed also includes 16 towns, 29 villages, 16 First Nations, and many resort villages along the lakes. Economic activity within the watershed include agriculture, tourism, potash mining, and oil and gas development. Agriculture, both crop and livestock production, is an important economic driver within our watershed. Potash, oil, and gas extraction are more localized, yet also important economic drivers. Recreation-based tourism is another important support of our watershed economy, and this is particularly true of our Lower Qu'Appelle. Our vision is a long-term, stable, high-quality water supply for people and for the environment. Water quality in the Lower Qu'Appelle Lakes will be able to support recreation, fishing, and economic development within the ecological limits of the system. Key components of our plan are water quality, quantity, and flow, industry, upland water management, and wastewater management. A watershed is an area of land that drains water or snow into one location, such as a stream, lake, or wetland. These water bodies supply our drinking water, water for agriculture and manufacturing, offer opportunities for recreation, and provide habitat for numerous plants, animals, and insects. Unfortunately, various forms of pollution, including runoff and erosion, can interfere with the health of our watershed. We have partnered with many stakeholders over the years to bring awareness and education and share the importance of protecting the quality of our watershed. We may be urban dwellers, lakeside dwellers, or we may be agricultural producers. But we all have something in common, and that's managing the piece of land we live on, and we want to do our best at protecting our environment, our lakes, streams, rivers, and our very own backyards for us and for our future generations. Even the local turtles manage their own backyards. Do we have a nutrient problem? Those pictures show that we do. What is that, and where does it come from? Our watershed, as determined by the 2010 State of the Watershed Report, is classified as stressed. This means that although our watershed has no degradation in function or the services it provides, it simply means it has lost resistance to change. Here in our watershed, water is used for many purposes, including environmental needs for the flora and fauna of the watershed, and the many human needs, including source water, recreation, industry, and agriculture. First, our climate and landscape can make it challenging to keep nutrients on fields. Crop growing season is short in the prairies. When snow accumulates on fields, nutrients can dissolve into the snow and wash away in spring. Snow melt is a key source of runoff and a critical period of nutrient transport on the prairies. Unfortunately, many beneficial management practices developed for warm conditions or soil erosion control do not work at full capacity with prairie climate and landscape. Secondly, our lakes are highly vulnerable to nutrients. Prairie lakes are often shallow, With large watersheds encompassing agricultural land, these factors can make prairie lakes even more vulnerable to nutrient pollution and algae blooms. Finally, some management practices, such as reduced tillage and bale grazing, can build up nutrients on the soil surface and thus increase nutrient export with snowmelt runoff. As a result, we must act to minimize nutrient transport if we want to help address growing problems in our prairie lakes. Referring back to our beautiful pictures of blue-green algae, scientists are telling us that these blooms are happening more and more because of us. Remember when I said we all manage our lands, no matter who we are or what we are living on? Adding phosphorus and nitrogen into a mix of nutrients that are keeping our water residents well fed year-round disrupts this balance. Where are they coming from? Well, sometimes it comes naturally from the soil or from decaying plant matter, but far too often it's coming from us. For example, look at our beautiful lush green lawns. Do you use fertilizer to keep yours looking nice? It's hard to imagine that we can have an impact on a water body the size of a lake, but we do. Scientists are also showing us that water runoff into our lakes, rivers, and streams also has a lot to do with excess nutrients getting there. The lake kind of acts as a collecting bed for those nutrients and chemicals because water flows across the ground from snow melt and heavy rains and collects in lakes. What we do in our watershed on the land influences what happens to our water. Remember, according to the State of the Watershed report, our watershed is already stressed. Did you know that the Lower Qu'Appelle Watershed Stewards have a committee called the Qu'Appelle Basin Research and Monitoring Committee? Our committee members include myself, the manager from Walkwater, the manager from the Moose Jaw River Watershed, a senior agrologist from WSA, and an ecologist and a water quality scientist from the Water Quality Services Department of WSA. From time to time, we also invite other people to participate, depending on what projects we are working on. We developed the research plan based on these two questions. What are the current nutrient loads in the Qu'Appelle River watershed, and what are the proportional contributions of point and non-point nutrient sources? Water Security Agency undertook a Qu'Appelle mass balance study and examined the concentration and load of nutrients entering, being retained, and leaving the Qu'Appelle River and tributaries within our watershed. This was done over a 3-year period. The study did not specifically evaluate agricultural contributions to overall non-point source nutrient loading to the Qu'Appelle River or its tributaries. Nor did the study consider the quality of water as it relates to a raw source water used to produce potable drinking water. Drinking supplies are already regulated for safety by WSA in cooperation with municipalities through the watershed. The Qu'Appelle Nutrient Mass Balance Study found that the Moose Jaw River and Wascana Creek were the largest individual tributary sources of nutrients to the Qu'Appelle River. The Regina Wastewater Treatment Plant was found to contribute 9.3% of the phosphorus and 52% of the nitrogen load entering Pasco Lake. After the wastewater treatment plant upgrade, it is estimated to have decreased to 6% of the phosphorus and 15% of the nitrogen load entering Pasco Lake. The ongoing monitoring will better quantify the improvements arising from the Regina wastewater treatment plant upgrade. And we'll talk about the municipal wastewater and the ag nutrient land use study in the next few slides. This slide indicates the testing points that WSA tested at for their mass balance study. The blue points indicate the tributaries and the red points indicate the testing sites within the Qu'Appelle River system. So to sum up the 3-year study, there were 949,000 kilograms of phosphorus and 6,434,000 kilograms of nitrogen. And to give you a better perspective of just how much that is, it's the same amount of nitrogen as putting over 1.2 million 50-pound bags of 10-010 fertilizer into our water. As mentioned earlier, the City of Regina completed upgrades to their wastewater treatment plant. This upgrade to the plant was required to meet the province of Saskatchewan's higher effluent requirements and to accommodate future growth. The new facility now meets higher effluent quality requirements, specifically regarding the reduction of nutrients that can cause damage to water bodies, thus improving conditions for aquatic life. The new treatment solutions will also reduce nutrients that can damage the environment from re-entering the river, helping to improve conditions for aquatic life in the Wascana Creek and Qu'Appelle River system. What about municipal lagoons? One of our research projects was nutrient loading into the Lower Qu'Appelle watershed. This study looked at the mass nutrient loading from municipal wastewater treatment systems that discharge effluent into the Qu'Appelle River Basin from 53 communities. This report assisted us to develop a better understanding of the municipal sewage effluent has on the quality of our watershed. Looking at those results, 7 out of 10 tributaries have a % contribution of nutrient loading from municipal sources of less than 5% for phosphorus and nitrogen, which shows that nutrient reduction in municipal effluent from these tributaries will likely have minimal impacts on the water quality. However, the 3 tributaries most affected by municipal effluent include Wascana Creek, Moose Jaw River, and Last Mountain Creek, which receive effluent from Regina, Moose Jaw, and Humboldt. Cities have the largest impact on the watershed due to their large volumes of discharge as a result of their higher populations. Therefore, in order to reduce the stresses on the watershed, better results will be seen by improving effluent quality in Regina, Moose Jaw, and Humboldt. These 3 communities account for 81.6% of the phosphorus and 97.46% of the nitrogen being released into the watershed from municipal sources. This graph just shows you municipal versus non-point sources. This graph just gives us a closer look at the highest contributors. As you can see, the total phosphorus loading from municipal sources, most of it from Regina. The total nitrogen, again, most of it from Regina. So you can see that after the upgrades, it's a huge difference to our watershed. This graph shows the municipal and non-point sources. As you can see, the black is non-point and the gray is municipal. Now for the good news, a closer look at our highest contributor in the past, the City of Regina. There's been a decrease mass loading into the watershed from point sources by 62% for nitrogen and 8% for phosphorus. Now let's talk about land use and water quality. Now we know what an upgrade to a wastewater treatment plant can do, but what can we do about other nutrients? Nutrient management is a challenge. Producers need to apply large quantities of phosphorus and nitrogen to support their crop growth, but just a small amount in water can cause environmental consequences. Here are some things to consider to protect water quality in the prairies. Follow the 4R principles. Fertilizers and manures should be applied following the 4R principles. Example, applying nutrients at the right rate and right timing, using the right source and right placement method. Avoid nutrient application in winter and on snow-covered or frozen ground. The majority of runoff in Saskatchewan and the majority of nutrient loss is part of the winter snow melt. If fertilizers are on fields late in the season, key nutrients are likely to wash away in spring. If possible, avoid winter application or target winter manure to low-risk fields that won't drain into local streams. Increase fertilizer injection. Phosphorus runoff is tied to interaction with snowmelt. Another option for reducing nutrient runoff is injecting fertilizer and manure into the soil to minimize contact with snow. This must be done before the ground freezes. Remember, vegetation is also a nutrient source. Forages, cover crops, and crop residues contain considerable amount of nutrients. A large proportion of nutrients can be released from vegetation during the freeze-thaw cycle, so exercise caution with cover crops on the prairies. Depending on climate and soil conditions, the nutrients released during freezing winters may be reutilized by crops or may be washed off the fields by runoff. We partnered with the Global Institute for Water Security to undertake a report on the land use and water quality. No one has undertaken a study like this before, so this is a good step in the right direction. This report assessed the potential impact of various beneficial management practices in the Lower Qu'Appelle upstream of Round Lake. This report is a screening level assessment of the potential impacts of BMP implementation and is limited by the lack of data on the effects of management at relevant scales and environmental condition, and attempts to tackle one of the most difficult areas in watershed management. Estimating efficiencies of BMPs in nutrient reductions from a data-limited watershed. Given the data limitation, the report represents the best possible assessment of BMP impact, but it should be seen as a representation of what we might see rather than what we will see. So, documenting the ag footprints. The researchers used the ag census data, the drainage inventory data, the land cover data, literature to estimate the nutrient contribution of each activity, and estimate the potential range of load for each of the tributaries. So best management practices assessed were fertilizer management, fertilizer nutrient management, relocation of manure spreading to non-contributing portions of the watershed, cattle management, management of cattle wintering sites, riparian grazing management, crop management, conversion of fallow fields to annual crops to perennial forage crops, and watershed management, wetland restoration. Assessment results include fertilizer management, some benefits with improved management of fertilizer inputs. The relocation of manure spreading is expected to have relatively small effects. With cattle management, managing the urine and dung from farm animal access to streams is expected to be worthwhile. Other results show that crop management clearly needs more study. Watershed management impacts of drainage are potentially profound, and restoring the ability of wetlands to hold water on the landscape and reduce annual discharge volumes to streams has the potential to reduce in-stream phosphorus and nutrient loads. Here in this slide, you can see that the prairie pothole is filled up by March, early April, and by mid to end of April, it is fully drained. As you can see, wetland drainage has the unintended consequences of releasing nutrients downstream. This slide shows with less wetlands, more water with phosphorus flows downstream. But if we reverse this and restore wetlands, the opposite happens and more nutrients are kept out of the lakes and rivers. Restoring wetlands is a simple process. By constructing an earth plug in the ditch, a wetland can be fully restored within just a few years. LQWS and Ducks have programs that can assist farmers in restoring their wetlands. So we know agriculture affects water quality. However, every producer can make the decision to minimize their individual impact. Now we know we can do better. We can do better at managing our lands. We can manage our nutrients by reducing the amount of nitrates and phosphorus, by retaining wetlands to store runoff and trap nutrients, restore the drained wetlands to store runoff and trap nutrients, practice those 4 R's, upgrade your wastewater treatment plants and reduce the amount of fertilizer on our lawns, and ensure that our sewage holding tanks aren't leaking or seeping into our lakes. If you have any questions or want to view the reports, you may go to our website at www.lqws.ca. Thank you.